So in this video, we are going to see about the electronic devices in that LED light emitting diode. So this is under the module 4. So introduction about LED. LED we know it is one type of diode which emits light energy. It is a semiconductor light source, we can say. It was founded by Nick Hallam in the year of 1962. Initially, when it was found, it was in red color LED. So it is a special type of semiconductor device, semiconductor diode. As usual, we are having two PN junctions. One it is anode and a cathode. You can see this LED has created a revolution in digital world, and the application of LED it was up to the sky level, and the fundamental starting from the scratch to the higher end applications use of only LED finds its major role here. So initially there was the LED was found as a replacement for lamp. So lamp it consumes more amount of energy, and also the intensity of the light produced from the lamp is also high. So while comparing with the lamp, LED was low power consumption one, and its light was up to the mark. So it was found by Lick, and it occupies a very smaller area that will be within 1 meter square. History of LEDs. First initially Soviet patent he was invented the LED is as a light relay, relay. So it is a device that actuates or switches the particular another circuit. So LED, when light falls on the another circuit, it will be actuating the other device. In 1929 itself, he has got a patent on light relays. It is the first thing it was awarded, and after that 1961 to 1962, modern LED, we are using the modern LED that was invented by Texas installer, especially by Nick. After that, 1962, red color LED was invented. It was the first color. Now, in recent industries, we are having more colors of LED. Now we are having first at the invention of it was invented as red color, and it was the primary use of LED. It was for indicating lights. After that, in 1970s, it was used in vertical displays. We are seeing right in traffic light indicators and various industry purposes. If there is an alarm, or whether we are using fuses in poles, so that is also an LED. So for indicating purposes and for testing purposes, 1970 was used. 1970s, and it has given more light than compared to the usual lamp, that is nearly 10 times higher intensity than lamp. And the first color LED produced it was red. Then these are the applications of LED. 1980s traffic signals, 1990s automotive lamps, and 1990s the blue LED was invented. The blue LED gave the high intensity than the red light. And after that, RGB colors, the red, green and the blue colors become the practicals. And in 2000s, different colors of LED with the post coding was available. What is an LED? LED, as usual, it is a light emitting diode. It will be available in different colors, not restricted to the RGB colors. It may available from a wide range of colors, and because of the material used, we are getting the different wavelength of LEDs. So there are also white LEDs available. So this is the anatomy of an LED, this internal structure. It will having an heat sink, and after that an board that to carry that heat sink, and we are having an emitter from the board, and we are having the dielectric material in between the emitter and the MCB, and this emitter will have the semiconductor part. So after that, the semiconductor part, it will have the metal junctions for the provisions of anode cathode. How an LED works. So as like said, LED it is a simple diode. So a diode, when it is forward biased, the electrons and holes will move faster, and they will combine, and it produces heat energy. So in LED, instead of producing heat energy, it produces the light energy, and so when the electrons and holes recombine, it produces the light energy. This is the basic difference between a diode and an LED. So in diodes, we are using the direct band gap materials, so like silicon and germanium. In LED, we are using the indirect band gap materials like gallium arsenide, indium phosphide, gallium nitride. These are some of the materials which have an indirect band gap. So in indirect band gap materials, the momentum between the valence and the conduction band will differ. They are not occur at the same level. So due to the difference in the valence band and conduction band momentum, instead of heat energy, light energy will be produced. This is the basic principle behind LEDs working. So as usual, P-type semiconductor and N-type semiconductor will be brought together, and when brought in due to the diffusion of magnetic carriers will take place, and due to the diffusion, the recombination takes place. The recombination of electron and hole pair will release the light energy, as same like a diode. And so this is the structure of an LED. So on the below diagram, you are having two terminals. The longer one it is the anode, and the shorter terminal it is the cathode. If we have a flag-like structure, if both the terminals are the same length, you can analyze that the metal part. So if the metal part is like a flagger-like structure, it is the cathode, and another terminal it is the anode. Basic components in an LED. So where we are using, like in chips, in packaging. So LED finds its role up to the sky level limit. So where we can find LED wherever all the places. So these are the very small applications where LED finds its role. This is very small LED. The first part it is the right LED nano. That one is used for lab purposes. We are using in lab, and the second one it is for industrial purposes. That will be very smaller. Like I said in the first video, LED find its area. It is 1 mm square. So that is very precise 1 mm. So currently we are using LEDs that are directional ones. So in traffical signals, in torch lights, and in relay paths, so to spot a light. So in these areas the LED will be used. So in tube lights, now LED tube lights came, and also LED TVs are also now it is moving, and switching over from normal LED, we are having organic LEDs also. So for in green revolution and light distribution. So some LEDs will have lenses to spread the light, and some LEDs will have will be focused or converged to the specific part. So based on the outer coating material we are using, that is the glass part we are using, the light of the LED will diverge through the areas. Yes, as we said in first slide, it is diodes will produce a heat energy, LEDs will produce light energy. It is a myth that LEDs doesn't produce any heat energy. No, it is not like that. LED will also produce a heat energy, other lighting sources. Supposing we are having an incandescent light in our home that produces 19% of heat energy, and the fluorescent light we are using, it produces 42% of heat energy. LEDs will also produce 75 to 85% of heat energy. LED will also produce heat energy and also produce light energy also. This is the light output versus the junction temperature. So different colors of LED will produce a different characteristics curves. So based upon the material we are using, the different light energies will be produced. So different light energies will give different characteristics curves. So how we can manage the heat energy? So when we are going for heat management, we have to enclose LED in a good casket, that is good sealing you have to use. So for that sealing there are numerous varieties available. So these are some varieties that we can use for casketing. Yes, you can say how we can produce a white LED. So white LED can be produced by combining the red, blue and green energy of the proper wavelength consigned to a particular window. It will produce as a white LED. Advantages of LED. So smaller in size, it has higher efficiency than normal lamps, and life expectation of LED is also high, very high life. And we can make the LED to dimmer or brighter based upon the input voltage we are giving. LED will be operating with low temperatures and low voltages, and it is toxin free. These are some of the advantages, and there are a few challenges in LED also. So cost wise, on bulk requirement, the cost wise will be higher, and when you switch over to different lights of LED, different colors of LED, the material we are using will be changing, so that material will cost high. And the directional distribution, it is not consigned to a particular part, it will give a divergence of light, so that is also a bigger challenge. And performance wise, we can say it is a semiconductor, so when it is go to a insulator state, we can say, so that is performance wise we have to look at. And different life efficiency also is there. And we can't replace LEDs. Replacement will be cost high. So the best applications of LED, it is rounding in the clock, from the clock to traffic signal to the monitors we are using, displaying unit, all those applications find best applications of LED. In industry also, we are using for in displaying devices, and a wide range of LED applications are there. And in a traffic signal, mobile phone display, and in motorcycles and the display of fuels. And LED finds its role in home, like from bulb, TV to iron box indicator. So a variety of applications are available for LED. And on comparison with lamp, LED will be very much cost effective, and light intensity will be higher, and temperature the voltage, incoming voltage will be less. And advantages, it is cost wise is less, and it occupies very lesser area, and when it is connected with the electricity, there is no interface, magnetic interfaces like lasers. and based upon the intensity of LED we are using, we can control the microcontroller of other devices, like like a relay, like a right source relay we can use. So on a quick recap, LEDs are the diodes, semiconductor diodes, two terminal diodes. So it is having normal PN junction. The materials used for LED will differs from the normal diode, that they are in indirect band gap materials. Direct band gap materials or normal diodes, they emit heat energy. Indirect band gap will emit the light energy. So different materials will produce different colors of light. So for example, gallium arsenide, it will produce the red color, and gallium nitride produce an blue color. So different, if you want a different color LEDs, different light intensities we are using, means we have to use the different semiconductor diodes. So if we want white color LED, we have to mix up with the red, green and blue color, and based upon the different materials we are using, the characteristics curve will also differ for LEDs. LED will also have knee voltage or cut-in voltage of 0.7, and but it differs for different materials. So it is also having the knee voltage, and it can work only in the forward bias condition. In reverse bias the LED doesn't work. So application, it have wide range of application advantages. Yeah, one more thing I want to say, it is LED works in the principle of spontaneous emission. Okay, thank you.